Welcome back, chemistry fans. Today, what we're going to do is the Unit 7 exam. This time, we're going to do the multiple choice portion of the test. Let me share my screen with you, and we'll get started right away. Okay, so on this test, what we end up with is trying to talk about the different bonding styles, and we got to analyze it. Okay, so let's start with question number one. Instead of working backwards, let me go and find it actually here. A couple more slides back. Okay. Question number one says, which of the following has the shortest bond length? The answer to this one is the molecule that has the most bonds. So we have a double bond with oxygen, we have single bond with bromine and iodine. So the nitrogen is going to be the shortest because as you add more bonds, they pull in closer. All right, number two. It says, which of the following molecules contains a central atom with an sp2 hybridization? So what we've got to do is just look at this central atom here and notice what is being told of you. Don't assume that there are extra electrons when there are not. Beryllium and boron have this weird scenario where they are accepting of just having stable duets or stable hexets. So, and then we have so what we're looking at is the number of ligands here. And what the sp2 would mean is that it would have 3 ligands. Well, this has 4. I'm sorry, this molecule has 4, this molecule has 2, this one has 5, this one has 3. Therefore, that is the answer that we are looking for the sp2 hybridization. Question number 3. All right, which molecule is the least polar? Well, it's the one that has the most symmetry to it. So if we were to cut this in half, this left side does not look like the right side. If we cut this molecule in half, the left side does look like the right side. If we cut it sideways, the top looks like the bottom. This is our best answer because we're not going to see this symmetry anywhere else. So C2H6 is your least polar. All right, number 4. Which of the following has no dipole moment, is nonpolar, and shares electrons equally based on its shape, just based on shape. So this one is a bent molecule. That is not. This is a trigonal. It is polar. This is also bent. So that leaves us with the one that you might think is actually a little bit polar just based on the way it's drawn. But in fact, it is going to be the least polar. It is a trigonal pyramid, and it will have, square pyramid, and it will have some stability where the others are a little bit more polar. All right, number 5. Now, this one, it's a graph that you may not be familiar with until you start looking at what we have. Intermolecular distance means the bonding length. So X is going to be the one where we have, where is the highest amount of energy with the shortest distance. So X is going to be essentially the highest energy with its shortest distance. X is going to be the triple bonded one. And then next comes Y. It's harder to remove that one. And so it's actually going to be then the double bond, which is the O. And then finally is going to be the Z. And that one is going to have the single bonds, the H's. So Z. So that's going to come right there on that first one. All right. Number 6. So on this one, which of the following molecules have resonance structures? In other words, which one has a double bond that's going to float around? No double bonds, no double bonds. Double bonds, yes, but they're on both of them, so it won't matter if you switch them. So the only one that has resonance is the SO3. Number 7, what is the hybridization for the carbon atoms that are in C2 H2, C2H4, and C2H6, and those molecules are drawn out here. So looking at the hybridization, we would have 4 ligands here. We would have 1, 2, 3 ligands here, and we would have 4 ligands. I'm sorry, we'd have 2 ligands here, only 2 ligands here, sites where they are bonding, not number of bonds. So what we are looking for is SP, SP2, and then finally SP3. So that is that third choice down in there. Number 8, how many sigma and pi's are in this? Well, total. So first bonds are always sigma bonds. So there are 2 of those, and second bonds or triple bonds, they are always going to be the pi bonds. So 2 and 2, that's your first answer there. Number 9. What is the approximate bond angle between the C, the H, and the O in the following structure? So if we just look at what this is, making certain that you understand that that means that it is a bent structure. Now, it is a bent structure inside of 4, so that means it was tetrahedral. That means it's going to be approximately the 109-degree angle. What is the relationship between both the atomic radius and the ionic charge when there is an increase in lattice energy? So what that means is that the atomic radius, it's harder to pull apart. The lattice energy is going to increase when the atomic radius decreases. So these are going to be out. The closer they are, the harder it is to pull apart. Now, ionic charge is also going to increase because the higher the number of charges, the more bonds there are. So we got this third choice in here. The decrease, the sizes are going to get closer together. It's harder to pull apart, and it's harder to pull apart whenever you have more charges. So that takes care of that choice. Now we are at number 11. Which molecule has polarity based on a size comparison from the periodic table? So if we have OBR, that's quite the size distance. They are on different energy levels. MN and SE on the same energy level. CO on the same energy level, and AL, CL all on the same energy level. The only one that has a difference in their energy levels is OBR. That's where we're going to see the greatest polarity difference based on size. All right, question number 12. What is the bond order? So bond order is number of bonds divided by the number of locations or ligands, if you will. So we have 3 bonds in 2 locations. It's going to be 1.5. I don't know if there is a second question down below. There is. Using the chart, what is the ionic character for CSN? So C is 2.5. SN is right below it, 1.8. Subtract the difference, you get 0.7. That is polar covalent, slightly polar, not really. And that is going to, I believe, be the last question on the test. Let me see here. I think that was it. Yep, that was it for us. Okay, well, thank you very much for calling in, staying in here while we try and get you some answers, some solutions, make those corrections, show me proof that you understand it, not only just my answers. Go through the definitions, go through the formulas, make sure that you include your explanations for why these are correct answers, just as I went through. All right, thank you very much. Talk to you again soon. Bye-bye.